Hey everyone, and welcome to the Math League Media YouTube channel. Today we're going to be going over sprint number 25 from our 12504 release, which was one of this year's high school releases. Problem number 25 reads, a time between 12 a.m. and 2 a.m. on the same day is selected uniformly at random. Compute the probability that at that time the smaller angle between the minute and the hour hands on a 12-hour analog clock at that time measures less than 90 degrees. Now, thinking about a clock with its hour and its minute hand. Well, first of all, at 12 a.m., both its hour hand and its minute hand are pointing to the same space, the 12 a.m. marker. Every hour, the minute hand makes one full rotation around the circle that is the clock. So the minute hand, each minute, travels 1/60th of 360 degrees, or 6 degrees. And the hour hand travels one full revolution around our circular clock every 12 hours. So it's going to move 360 over 12 times 60 degrees in 1 minute. And since 360 is 6 times 60, then 360 divided by 12 times 60 is going to come out to 1/2 of a degree each minute. So then the minute and the hour hands are moving away from one another at a rate of 6 degrees minus 1/2 degrees every minute, or 11 halves. And notice that as the minute hand completes its full circle, that first in a cycle it's going to end up at a 90-degree angle to the hour hand like this. Then after another 90 degrees of motion, it's going to end up parallel and pointing away. And after a third 90 degrees of motion, it's going to point in a 90-degree angle in the opposite direction as our first incident. And then finally, they're going to once again point in the same direction after another 90-degree interval, after which the cycle repeats. So while we're in this quadrant of motion and this quadrant of motion, then the angle, or the smaller angle between our minute and our hands, is going to measure less than 90 degrees, which is what we want. So what we want to figure out here is how often in between 12 a.m. and 2 a.m. is the angle between the minute and the hour hand contained in either this quadrant or this quadrant. We move from quadrant to quadrant whenever this difference ends up changing by 90 degrees. And again, since these hands move 11 over 2 degrees away from one another every minute, then in our first, from our first interval to our second interval, we're going to have it make a motion of 90 divided by 11 over 2 minutes to get to this first point, thereby transitioning from this quadrant to this quadrant. And the minute and hour hands will form this 90-degree angle at 90 over 11 minus 2, or 180 over 11 minutes. They'll be parallel at 180 over 11 over 2 minutes, but we don't really care about when they're parallel. We only care about when they're forming a right angle, because that's when they transition from having a smaller angle of less than 90 degrees to a smaller angle of more than 90 degrees. So we don't care about the 180 over 11 over 2, but we do care about 270 over 11 over 2, or 540 over 11. Similarly, we don't care about transitioning from this quadrant to this quadrant, so we can skip over 360 over 11 over 2, but then we do care about our next interval, which is 450 over 11 over 2, which comes out to 900 over 11. We don't care about transitioning from this point, but we do for this one, so our next consideration is not 540, but 630 over 11 over 2, or 1260 over 11. And notice that between 12 a.m. and 2 a.m., there's a total of 120 minutes. And 1260 over 11 is less than 120, but if we increase further, then we're going to end up with a fraction that's greater than 120 minutes, which means that we're going to be past 2 o'clock. This also makes conceptual sense because when we make it from one of the times when these two hands are pointing at the same direction to the next time these two hands are pointing in the same direction, then the minute hand has moved a little bit further than a full circle, which means that a little bit more than an hour has gone by. So we can't go past the second time these two are pointing in the same direction. That would be more than 2 hours. So these are going to be our shift points in our problem. These are the minute times when the minute and the hour hand switch from having a smaller angle between them that's less than 90 degrees to a smaller angle between them that's greater than 90 degrees. So, and we know that since they start pointing in the same direction, we start with our desired case being turned on, essentially. And that is the case up until we reach minute 180 over 11. So for a minute length of 180 over 11 minus 0, then the requirement of the problem will be satisfied. Then from 180 over 11 minutes into our time to 540 over 11 minutes into our time, that's the off case. That's the case that we don't want, so we won't count that. But from the 540 over 11 time to the 900 over 11 time, we're once again switched on, which means that for another 900 over 11 minus 540 over 11 minutes, our case is satisfied. And then finally, from minute 900 over 11 to minute 1260 over 11, we're in our off case. But then from minute 1260 over 11 to minute 120, we're going to have our case satisfied. So in this 120 minus 1260 over 11 minutes, our desired case is satisfied. Now, this is the sum of all of the minutes that are satisfactory to our desired case in our problem. So all we need to do is add these up. I'm not going to do the rote addition and subtraction for you all because I'm sure you know how to do that on your own. And it comes out to 600 over 11 minutes. Now remember that we were asked for the probability that this is the case, and this is true for 600 over 11 minutes out of a total of 120 minutes between 12 a.m. and 2 a.m. So to get our final probability, all we need to do is divide 600 over 11 by 120, which comes out to 5/11ths as our probability. And that is it, and we are done. Thank you.
Hey, this is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.